So for this lesson, we are going to learn how to solve singular inequalities. Our goals is to be able to say, I understand what a singular inequality is. Also, we want to say, I understand how to solve singular inequalities. So let's dive right on in. First, we're going to start with some vocabulary. So some key vocabulary. First off, an inequality we know is a math statement that compares two expressions using a relation symbol that one value is larger than, smaller than, or equal to another value. Inverse operation is an operation that undoes another, so add and subtract are inverses of each other. Multiply and divide are inverses of each other. And then we have isolate. That means to get the variable alone. That's when we're trying to solve. And we get a solution set, which is the values of the variable that makes the inequality true. So we're going to be using inequality, inverse operation, isolate, and the solution set. So we filled this out in our last notes, but we're going to do it again today, just for a nice little review. So remember, less than is a, get the right thing here. Less than is a open circle. Greater than, this symbol down here means greater than. Wow, if I can spell. Greater. There we go. Greater than. There's a reason why I teach math and not English. It's open and it will be pointing to the right. I just noticed that there too. Anyway, okay. Less than or equal to, that will be a closed circle going to the left. And then this is greater than. See if I can spell it right this time. Greater than or equal to, which is a close going to the right. So that's kind of what our inequalities mean and how we're going to use them. Okay, helpful steps to solving singular inequalities. We got to keep moving this little thing around. First, we need to simplify both sides, just like we did with equations. We always need to try to simplify first, the left side and the right side individually, before we start trying to isolate the variable, which is step 2. So isolate the variable, add or subtract, divide and multiply to solve for the variable. Remember, the order in which you use these depends on where the variable is located. We learned that in your equations module. And then number 3, check your solution. Substitute it back in, make sure it actually works. So let's go through these and solve some of these examples and follow along in your guided notes. So first we have x plus 5 is greater than 9. So we have a plus 5. The inverse is a minus 5. And once again, you can kind of picture this as two sides of an inequality or an equation. If I minus 5 from the left side, I have to minus 5 from the right side. So that disappears, and I end up with an x on this side and a 4 on this side, and then I just bring down whatever my original sign was. So in this case, I have x is greater than 4. So the way we would plug that in is just pick some number bigger than 4. So let's pick 5 and throw it in. 5 plus 5 is 10. Is 10 bigger than 9? Yes, it is. So we got the correct solution. Easy peasy. Okay, x divided by 2 is less than or equal to 6. We're going to go ahead and opposite of divide is multiply. We're going to multiply both sides by 2. Those 2 cancel out because it turns into a 1. 2 divided by 2 is 1. So I get x is less than or equal to, we just bring that same sign down. 6 times 2 is 12. So we can pick a number less than or equal to 12. So let's just pick 12. If I plug 12 back into my equation, let's get a different color. So let's say I plugged a 12 in right here. 12 divided by 2 is 6. And is 6 less than or equal to 6? Yes, it is. So we got ourselves a correct solution. Okay, next, this one looks like we're going to have to do 2 steps to figure this out. It looks like both sides simplify. That's something I failed to mention in the previous 2. Notice there was nothing I could combine on either side. There was no like terms, there was no distributing. So it was already simplified. This one, it's already simplified as well. There's nothing else I can do, so I'm going to go straight into solving. Now notice, since this x plus 6 is in the numerator of a fraction, I'm going to get rid of the denominator first. So I'm going to multiply both sides by 3 for that to cancel each other out. And I get x plus 6. Bring down your sign, greater than or equal to. 5 times 3 is 15. All right, now we just keep going forward. This is now just like a one-step equation. We're going to minus 6 from both sides. And I get x is greater than or equal to 15 minus 6 is 9. Okay, to check my solution. It says x is greater than or equal to 9, so I'm just going to pick a 9. So I'm going to plug a 9 in right there. 9 plus 6 is 15. 15 divided by 3 is 5. Is 5 greater than or equal to 5? Yes, it is. So I found my solution. Awesome. Okay. All right, now on this one, it looks like we do have to do a little bit of simplifying before we start doing any of the inverse operations, because we have a distribution. So we're going to take this 2, and we're going to distribute it into the parentheses. So 2 times x is 2x. 2 times a negative 4 or a minus 4 is a minus 8. Bring down your other side. And now I can solve it like a 2-step inequality. So we're going to add 8 to both sides. And we get 2x is less than 24. Then we're going to go ahead and divide both sides by 2. And we get x is less than 12. Let's double check that. Let's pick a number that is less than 12. Let's pick a 10. So if I plug the 10 in right here, 10 minus 4 is 6. And then 2 times 6 is 12. Is 12 less than 16? Oops. Yes, it is. So we got a correct solution. Okay, there is one more rule you need to worry about when it comes to inequalities. You need to understand that whenever you're multiplying or dividing by a negative, the inequality sign must flip. So, this part's not in your guided notes, but for example, if I had a negative, actually we have an example of it right next. Boom, here we go. So here I have a negative x divided by 24. Okay, so I'm just going to solve it like a regular inequality. We're going to divide both sides by a negative 2 first. And negative 2 and negative 2 cancel. And I'm left with x on this side. And 24 divided by negative 2 forces it to change signs. So instead of a positive number, it's going to turn into a negative 12. And the fact that it changes the sign when I multiply or divide, that forces this sign to flip. So my solution is going to be x is greater than negative 12. So let's plug it in and see if it's actually true. Let's plug anything bigger than negative 2. Let's just do negative 11. Okay. Negative 11 times negative 2 is positive 22. And we got 22 is less than 24, which is true. Now let's, just for experiments, Let's say, what happened if I didn't switch that? My answer would have been x is less than negative 12. So I'd have to pick a number less than negative 12, like a negative 13. And negative 2 times negative 13 is 26, which is not less than 24. So see, it doesn't work if I didn't flip the sign. So make sure whenever you divide or multiply by a negative, your signs have to switch directions, because we're switching a positive to a negative or a negative to a positive whenever we multiply or divide by a negative. Let's take a look at another example to make sure it makes sense. So here we have a two-step inequality. We're going to go ahead and minus 8 from both sides. So that cancels out, and I'm left with an x. Well, first off, is there anything I could simplify? There's nothing I could simplify. There's no distribution. There is no combining like terms. So that's why I could just dive right on in to solving it. Okay, 13 minus 8 is 5. Okay, I haven't multiplied or divided by a negative yet, so my sign still stays the same. But right here on this step, look what's going to happen. I have to times by whatever the denominator is, which is negative 5. So I got to times by negative 5. Those cancel out. X, 5 times negative 5 is negative 25. So you see how it changed from a positive to a negative because I multiplied by a negative? That means instead of having it as a greater than, it has to switch to a less than to make it a correct solution set. So let's go ahead and check to make sure this is correct. X is less than negative 25. So we could do anything smaller than negative 25. Let's just pick a negative 30. And negative 30 divided by negative 5 is 6. 6 plus 8 is 14. And 14 is indeed bigger than 13. So I do have a correct answer. So just remember, multiply or divide by a negative, signs have to be flipped. So let's look at our goals we had. We wanted to understand what a singular inequality is. That's just one inequality. And then understand how to solve singular inequality, which we have. So we should be closer to achieving our goals. Go ahead and work on your assignment and reach out if you have any questions whatsoever.